Hello and welcome to this screencast on matrix addition, subtraction and multiplication by a scalar. So I'm going to go straight ahead and just define matrix addition. So if A and B are two matrices, the ith jth element of A plus B is equal to the ith jth element of A plus the ith jth element of B. So here we have a formal definition of matrix addition. And I'm going to go straight ahead with my first example. Okay, so I'm going to define two matrices, just going to make them up off the top of my head. Okay, so I've got one 2 by 2 matrix. I'm going to add another 2 by 2 matrix. So I'm just making these numbers up. Okay, so what we have here is the element in the first row, first column. We just sum them. So we have 1 and 1. So if I go 1 plus 1, okay. And the corresponding elements in the first row, second column are 2 and minus 3. So 2 plus minus 3 becomes 2 minus 3. Go down to the second row, add 3 and 0. So 3 plus 0. And finally, for the second row, second column, I have 4 and 2. So it's 4 plus 2. Okay, so quite a simple arithmetic now. So 1 plus 1 is 2, 2 minus 3 is minus 1, 3 plus 0 is 3, and 4 plus 2 is 6. Okay, so that's addition of those two matrices. You might notice both of these two matrices are of the same dimension. Now this is a requirement for matrix addition because let's say if this was a 3 by 2, okay, I'd have an element down here, but I wouldn't have a corresponding element here. So they have to be of the same dimension. Okay, so I'm going to go on to define matrix subtraction, and again using my A and B notation. So the ith jth element of A minus B is the ith jth element of A minus the ith jth element of B. So you can see it's the same as matrix addition, except we have a subtraction sign instead of an addition. So if I go ahead, I'm going to use the same two matrices as I did in example 1. Okay, but this time I'm going to subtract them. So I've got 1 minus 3, 0 and 2. Okay, so this time, instead of adding, do the same again, except I subtract. Okay, so slight difficulty here. We have a minus 3. So we have 2 minus 3, so that is in effect 2 plus 3. Okay, you've got to be careful on the negative numbers when you subtract. Okay, and that leaves 3 minus 0 for the element of the second row, first column, and I've got 4 minus 2, the second row, second column. Okay, as before, just evaluate the subtraction. So 1 minus 1 is 0, 2 plus 3 is 5, 3 minus 0 is 3, and 4 minus 2 is 2. Okay, so that's matrix addition and matrix subtraction. And the last thing I'm going to go over, if I just scroll down a bit, okay, I'm going to look at multiplication by a scalar. Now, if I have a scalar k, okay, multiplication by a scalar, so I'm going to multiply the matrix A by a scalar k. Now, a scalar is just a single number, single value. Okay, so the ith jth element of k times A is simply k, which is, remember, is a scalar. It's multiplied by the ith jth element of A. Okay, well, that may be a quite complicated way of describing it, but it's actually a lot easier. Okay, so what I'm going to do is I'm going to multiply my first matrix, 1, 2, 3, 4. Okay, this is example 3. Okay, so I'm going to multiply this 2 by 2 matrix by the scalar 2. Okay, remember this is just a scalar, just a single number. And so what we do is it's fairly simple. Every element in my matrix is multiplied by 2. So 2 times 1, I have 2 times 2, I have 2 times 3, and finally it's 2 times 4. Okay, that's all there is to it. So if I just evaluate those multiplications, so 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and 2 times 8. Sorry, 2 times 4 is 8. So that's all there is to it, really. Multiplication by scalar is just multiplying each element of the matrix by that scalar value. Okay, so that's matrix addition, subtraction, and multiplication.